All right, so what we have been doing so far with finding these zeros is we've been finding the places where our polynomial function is going to cross our x-axis. All right, now we need to break, or well, actually, not cross, but cross or touch the x-axis. And that's what we need to talk about next. Do we have touch points or do we have cross points for our zeros? Okay, well, first of all, we need to back up here and we need to talk about the multiplicity k. And that means how many times a zero appears, okay? So for this function g of x, when we set each factor equal to 0, okay, and then x plus 4 to the 7th equals 0 to find our zeros, okay? This first one will yield a 0 of 0, okay? But that happened 2 times, okay? So we say that the multiplicity is 2, okay? So we have a 0 of 0 with a multiplicity of 2, okay? That's what that's saying right here. On this one, what's going to make this be 0 is what inside there is 0, okay? So x equals 2, but that is going to occur because the exponent is 3. That's going to occur 3 times. So the multiplicity on that 0 is 3. Okay? This last one is going to yield a 0 of -4 with a multiplicity of the exponent 7. Okay, so the graph of a polynomial function, it says, behaves in the following manner based on the multiplicity of the zeros. So in the purple box, let f be a polynomial function and let c be a real zero of the function. Then the point C0 is an x-intercept of the graph of f. And it says if c is a zero of odd multiplicity, then the graph is going to cross over the x-axis, and that's called a cross point. Okay? What this means, like when you're graphing something, okay, is that if you know you have an x-intercept of, let's say, -4, like we did above, with an odd multiplicity of 7 at -4, this function is going to come here and it's either going to cross from the top to the bottom. It's going to cross it there, okay? Versus if c is a 0 of even multiplicity, then the graph only touches the x-axis at c, okay, and then it turns back around. It does not cross the x-axis. So for example, right here, where x is equal to 0, we have a x-intercept there when x is equal to 0, but this is only going to be a touch point. And what that means is that our function, okay, it crossed there because it was an odd multiplicity at -4. It's going to come up here and only touch here, okay? And then remember at this one, at x equals 2, okay, let's say that's x equals 2, we had a multiplicity of 3. That means since that was an odd multiplicity, it's going to cross instead of just touch. So those are the touch points versus the cross points. All right, and that's going to come in handy when we're sketching a graph. Now, I also want to tell you that another way this could have gone, and this will be determined by the leading term test to look at in behavior, this one could have also gone this, then touch, then come up a little bit, and then cross, right? So it could have been either the orange or the purple graph, loosely, okay? We'll put it all together here in a little bit. But there's the difference between a cross point and a touch point for that example of this function right here, f of x equals a negative x. The negative x corresponds to a 0 of x. And then the x minus 4 quantity squared, that corresponds to a 0 of 4. Okay, but the multiplicity of this 0 was odd, but this 0 was even. That's why at the origin we're going to cross, but we're only going to touch at 4, 0. Okay? So on example 4, it says determine the zeros and their multiplicities for the given function. Okay? So what we're going to do is we're going to take our function, the negative 2x to the 4th, times the quantity x plus 1 cubed, times the quantity x minus 2 squared, set it equal to 0 to find the zeros. Now we got a factor times a factor times a factor equals 0. Our next step is to set each of those factors equal to 0. Then the x plus 1 cubed equals 0. And then finally, the x minus 2 quantity squared equals 0. Okay? So at this point, you can already tell what the multiplicity is going to be for each of these zeros. Multiplicity of 4, multiplicity of 3, multiplicity of 2. Okay? You already know that. And so now we're going to do some algebra to solve. Okay, to actually find what those zeros are. First of all, if we divide both sides by negative 2 here, we'll have x to the 4th equals 0, and the only solution to that is when x is equal to 0. So x is equal to 0 is our 0, and it has a multiplicity of 4. Okay, that's going to be a touch point there. Okay, right here for the quantity x plus 1 cubed equals 0. What's going to make this be 0 is when the x plus 1 is equal to 0. When the stuff inside there is 0. Okay, so that corresponds to a 0 of negative 1 with a multiplicity of 3. So at the point negative 1, 0 on our graph, our polynomial function q of x is going to cross there because of the odd multiplicity. Okay? For this last 0, again, we're going to set the stuff inside the quantity equal to 0 because that's what will make the whole thing be 0. So our final 0 is x equals 2, and it has a multiplicity of 2. Right? Oops, I wrote that a little bit smaller than I really wanted to. It has a multiplicity of 2. Well, there we go. There's green. All right. Okay. Now, that's going to be another touch point. Okay, so we're going to have a touch point at 2, 0. We have another touch point at 4. No, sorry, 0, 0. And we're going to have a cross point at negative 1, 0, if we were to graph the whole thing, okay?